All right, IM2 classes. Today, we're continuing on with our graphing of quadratic equations. We are going to be graphing what is called um, intercept form, where we're going to be given an equation in this form, um, the a times x minus p times x minus q, this form. Um, and these are going to give us the intercepts, and we're going to graph those. Notice this is what a factored quadratic will look like. So when you take the quadratics, you do an x factor, you get the two binomials. So that's basically what we're doing. We're taking a quadratic. Um, if it's in standard form, if you were to factor it, that will give you the intercepts. And we talked about with solutions of quadratics. So here in this general form, P and Q are the intercepts. They're opposite. So if it's minus P, that means P is going to be positive. We'll see that when we're solving. We've talked about the axis of symmetry when we did graphing quadratics in standard form. The axis of symmetry, it just goes straight through the middle of the quadratic, vertex at the bottom. So this is all stuff we have done before. Let's go through. We are just going to look at a couple of quadratics. We're going to identify the axis of symmetry, vertex, and the x-intercepts. First, the axis of symmetry. The axis of symmetry is just the vertical line, it's imaginary, that goes through the middle of the vertex, the parabola. It goes through the vertex here. So the axis of symmetry, we call it A of S, that's going to be x equals, that's at 6. X equals 6 is the axis of symmetry. Then the vertex down there. I already put in the vertex at the bottom. All right. The vertex is at this point. So that's 6 to the right. So that's 6 in the x direction, -1 in the y direction. So there's the vertex. And then the x and y intercepts. We'll do this in different color. Let's do these in green. X and y intercepts are where not the x and y intercepts, just the x intercepts are what we're concerned with. It's where the parabola crosses over the x-axis. So our x-intercepts, there's going to be 2 of them. That's going to be at 5, 0 and 7, 0. So yeah, 1, 2, 3, 4, 5, 7, 0. And that's it. All right, so let's look at another one real quick. Find vertex, axis of symmetry, and the x and y intercepts. So I guess honestly, the vertex is probably easiest to find first. So here's the vertex. The vertex is at the point that's at -4 in the x direction, and then up 1 in the y, so -4, 1. Based on that, from that, we can find the axis of symmetry. That is then just the imaginary line that cuts through the middle of the parabola where it's symmetric on both sides, and that is at x equals -4. All right, and then the last thing, I'll do my x-intercepts in green. So we have one here that is at x -5, y coordinate 0, and then here that is at -3, 0. So we're just finding those on the graph. So moving on. Now, without a graph, we're going to do this algebraically. Identify the vertex, axis of symmetry, and the x and y intercepts of each graph. So if we hear the x-intercepts, set the factors equal to 0 and solve, x equals p and q. So we're going to use the zero product property. We are going to set each of these factors equal to 0. So it's going to be x plus 6 is equal to 0, and x plus 2 is equal to 0. I don't need these in parentheses. So set each of those factors equal to 0, and then solve for x on each of these. So this one, I'm going to subtract 6, and I'm going to get x is equal to -6. This one over here, I'm going to subtract 2. So I get x equals -2. So these are my P and Q. It doesn't matter which one you call which. These are P and Q. So from this, the x-intercept on this one would be -6, 0. The x-intercept on this one would be -2, 0. So on the intercepts, the y-coordinate's always going to be 0. So these are the two x-intercepts. The axis of symmetry. So the axis of symmetry, if we go back, if we look, the axis of symmetry is right in between those intercepts. All right. Since the parabolas are symmetric, it's going to cut right in between. So we need the x value in between -6 and -2. So the axis of symmetry, we have this handy formula where x is equal to p plus q divided by 2. All right. And these are p and q. So -6 plus -2. It doesn't matter which one you call which. Follow your heart. -6 plus -2 is -8. Divided by 2 is -4. So x is -4 is the axis of symmetry. And then the last part is the vertex that we need to find. I guess I'll do the vertex here. The vertex, then just like we did with in standard form, once you have the x to find the vertex, you're going to start with your original equation. And I am going to replace the x with our axis of symmetry, what we found there. So you need to remember the axis of symmetry is the x coordinate of the vertex. So if I put in -4 into x into the original equation, so it's going to be -4 plus 6, and then that's going to also be -4 plus 2. Now let's make them green to make it so we can see where that comes from a little bit better. So -4 plus 6 is, that comes out to +2. -4 plus 2 is -2. Run out of space at the bottom here. So 2 times -2 is -4. So our vertex works out where the x coordinate is -4 and the y coordinate is -4. There we go. So that's all. So let me do another one where a little bit more organized, have some more space to move stuff around. So starting off, I don't care about the 2 when I'm finding the x and y intercepts. I'm just going to take my 2 factors, x minus 1, set that equal to 0, x plus 1, set that equal to 0. And then solve each. So to solve this one, I add 1 to both sides. Solve this one, I subtract 1 from both sides. So over here, I get x is equal to +1. Over here, I get x is equal to -1. So the x-intercept on this one is going to be 1, 0. The x-intercept on this one is going to be -1, 0. So here are my x-intercepts. Now to find the axis of symmetry, I don't need to write out. I'm not going to write out the full word here. The axis of symmetry, the A of S, that's going to be x is equal to P plus Q divided by 2. Remember, these are P and Q, what we just found over there. So it's 1 plus a -1 divided by 2. 1 plus -1 is 0. Divided by 2 is 0. So the axis of symmetry is 0. Now we need to find the vertex. All right. Once we have the vertex, we're going to start with our axis of symmetry. We're going to start with our original equation. -2 times x minus 1 times x plus 1. And the 0, I'm going to take this. That's going to go in for my x's. So the 0 from our axis of symmetry goes in for the x's into the original equation to find the y coordinate of the vertex. So it's -2. So -1, +1. I'm going to change those x's to 0. This one, pretty easy to figure out. So this is going to be -2. 0 minus 1 is -1. 0 plus 1 is +1. -2 times -1 is +2 times 1 is still +2. So y is 2. So the vertex, again, we're looking for the vertex that's going to be at x equals 0, y equals 2. Again, the 0 comes from the axis of symmetry. All right. So now let's put it all together. We are going to graph the equations. What we want to do when we are graphing is we are going to plot the x and y intercepts, and then we are going to I think it's easiest to put the axis of symmetry right in the middle of it, and then find where the vertex is on that axis of symmetry. So here, the x-intercept starting off is going to be, don't need that parenthesis there. So it's x minus 7 is equal to 0 and x minus 3 is equal to 0. Solve each one of those equations individually. So add 7 on this one, add 3 on this one. So we get x is equal to 7 and x is equal to 3. So the x-intercept is going to be at 7, 0, and this one's going to be at 3, 0. So I'm going to plot those points. I'm going to plot them in blue. So the x-intercept's 3, 0, 7, 0. All right. The axis of symmetry. I don't need to do that formula. I know it's going to be right in between. So the axis of symmetry, I can just do this visually. So this is what makes it a little bit easier with the graph. I can just put that in there vertically. So the axis of symmetry, right? Hold on. So the axis of symmetry in red there, that is at x is equal to 5. So that's going through x equals 5. So look at the graph. So now I just need to find where the vertex is on that to plot the vertex. So to find the vertex, it's the same thing that we did last time, where we start with our original equation, where it's going to be y is equal to, that negative out in front is going to be important, x minus 7, x minus 3. I'm going to put that value from the axis of symmetry in for x. So it's going to be negative minus 7 minus 3, and I'm going to change those x's to 5. Whoa. Okay, hold on. Board is being weird. Whoa, whoa, stop it, stop it. There we go. Maybe, okay. All right, there we go. So here we have negative. So 5 minus 7 is -2. 5 minus 3 is +2. So -2 times +2 is -4. With the negative out front, that all works out to +4. So you really got to keep track of those positives. So the vertex is going to be at the point 5, 4. So that's going to be along this line on the axis of symmetry. I just need to go up to 5. I'll put the vertex in red as well. So right here, 5. And then that is all the information I need to finish graphing this here. And you know what? Let's just do one more. Oh yeah, that's a good one to do. So here I'm gonna find my x-intercept. So starting off, negative x is equal to 0, and then x minus 4 is equal to 0. So since there's nothing plus or minus in here, this one's actually real simple. You can divide by -1. You can, doesn't really change anything, but I know kids will get confused. How do you get rid of that negative? The negative, so it negative x divided by -1 is positive x. 0 divided by -1 is 0. figure out. You don't need to show any work on that. That one's pretty easy. This one here, add 4. So you get x equals 4. So the x-intercept here, this is at 0, 0. So when your x-coordinate is going to cross at the vertex there, this one is going to be, or the origin, this one's going to be 4, 0. So it's going to be at, let's do these in green this time. 0, 0, 0, 4. And then the axis of symmetry is going to be right in between the two. So the axis of symmetry is between 0 and 4. That's going to be right here. So that's going to be x equals 2 for the axis of symmetry. And now to find the vertex is going to be along that line somewhere. So to find the vertex, start with the original equation. And the 2 from the axis of symmetry is going to go into both of the x's in there. So it's going to be negative x times x minus 4, and replace those x's with 2. Work it out. Do what's in those parentheses first. So this is going to be negative 2 times 2 minus 4 is negative 2. Negative 2 times negative 2 is positive 4. So the vertex, we'll do the vertex in red, is going to be the point 2, 4. So 2 over 2 up 4 right here on that axis of symmetry. And then let's go ahead and connect with a nice curve. All right. That will do it for us. That's about all with the graphing of quadratics. We will see you guys next time.